Hello everyone. In this video I will try to demonstrate Lab 1 assignment and go over all the steps so that you can reference it while you are doing the lab or before you're doing the lab itself. So I'll start by looking at the notes. So these are the assignments. You may find your notes are slightly different, depends on the version number that you find here at the bottom. But mostly will the same material be there. Maybe like few sentences are different here and there. So the lab will cover the topic that we discussed in the class, which is the application security. And we talked about application security in the lab in the lecture, and we mentioned that uh, the attackers can exploit certain vulnerabilities, and we also mentioned that there are certain types of attacks. Some of them, like command injection, cross-site scripting, and SQL injection, are the ones they are basically exploit weaknesses in the programming, weaknesses in the developing of the software itself. Or probably that applies to most of the security attacks on applications in general. Today we're going to talk about only three of these attacks, um, not all of them, and we will use some simple Python code to demonstrate uh, this type of attacks, and we'll see the version of the weak version that can be exploited, and also the stronger version that prevent the attack from happening. So as usual, before you start, you need to log in to the virtual machine address, that virtual machine that you are assigned to, and at some point the instructor will give you an IP address. And once you get the IP address, you can create a VPN, and then you access the VM using SSH, either from Windows command line or using software like PuTTY. Regardless, you will be able to access the VM. And if you are using SSH, then or you should be using SSH anyways. So the password is MEILab123, and the username is student. Okay, so all of these applications are written in Python, as I said, and they are written as a single file application, so they are simple. We will assume that these applications are accessed externally from the web, but they are running on an internal server or internal host inside the network, even though some of these applications, for simplicity's sake, you will be running them on your virtual machine, so you'll be running them locally. But the assumption is these are somehow in real life they are executed remotely, right? And that's why the vulnerability here is dangerous. It is possible also that some vulnerable software will be still vulnerable and will be still subject to attack, even if it's run locally and it's accessed by users locally, right? So the attacks can be originated from local employees or local users still, right? So vulnerability is vulnerability, whether it's happening in a local application or an application that's accessed remotely. Just the vulnerability probably for an organization would be more damaging if the the application is exposed to the internet. So we'll start by the first example is the command injection example, and in this or command insertion, can call it that as well. In this type of attack, the user is exploiting uh, the fact that the application developer takes input from the user and use it to execute or to perform a function without checking the, the, the legitimacy of the input. And in this particular case, there are all types of injection, but in this particular case, it exploits uh, some features of, for example, Linux operating system that you can execute multiple commands in one single line, right? And the example that we're going to see here asks the user to enter an IP address for one reason or the other. Maybe we want to execute a ping, right, remotely. So I want to verify if a device is active. So the Python code says enter the IP address that you want to verify. The user is supposed to enter the IP address, and the application will go and ping that device and then reply or go back to this user and say, well, this device is active or not, right? This is the simple idea. Now, if the application goes ahead and does that without checking uh, the input, the input is supposed to be an IP address, all right? IP version 4, so 4 octets separated by four decimal numbers separated by dots. So that's the typical. But if the user exploits the fact that I may put more than just the IP address in the input, and assuming that if the application runs the command, it can run multiple commands at the same time, at the same shot, right? So, and this is what we will call the command injection. So here is the code itself. I'm just gonna go run the code, and then I'll come back and look at the code and see where the vulnerability is. So the code, if I say now the instructions say Python 3, I'll execute the code. Command injection, then I'll supply the address of the device that I want to verify if it's there or not. Let's assume it is the local device. It can be any address, so I'll just use the. So now a ping comes back with the reply, so I could ping this device. The application can go fancy and say, well, the device is active or something like that. It doesn't matter. If I change the IP address to something else, again, it works and the application comes back and say that device is active. Okay, so here's what I can do to exploit the vulnerability in this application. Let's say I am entering, or I will enter something that's more than just an IP address, and I put a quote there so that everything I enter, it will be used as an input to the application. So I am gonna go and put another command and enter the whole sentence there, the whole 888, and then semicolon ls-l. Now see here that the application didn't just reply with the ping, but also executed the directory command, the list of files in the directory. So now I know there's the directory is a flow manager, or the current directory has subdirectories flow manager, SDN, and security. Now, obviously, I can do that locally, and I see these folders. But if that's why probably just to point out that this is just an example. But if imagine that this application is running on a remote server, and you can't just simply do ls-l in that remote server, because it's the only access to that server is the application. But if I exploit the vulnerability of this application, I'll be able to list the folders, list the files in that folder. I can go even further and say, how about I check the routing table? So now, not only I pinged a device, which is the normal behavior that expected from the pipeline, but also listed all the files in the directory where the application is running, right? So the application, if the application is running on a remote server, I will be able to see where the files in that home directory of that application. And I also executed an IP route command, which will give me the routing table on the server that I'm running the applications on. So you can imagine doing more stuff here. So, okay, now that I know the folders, how about I'll check the specific folders. So now I'm just gonna go and check the SDN folder and see. So now I know each files in that SDN folder. So you see here, I'm going way beyond what the application was defined, and I can explore everything in that server. Normally, I shouldn't be able to do that, but the developers gave me an opportunity to exploit the application because they didn't check the input. Okay, so now let's try to use the safe version of this. The safe version, I can use it by adding an option -s. So now the safe version works as expected. It will give me the ping reply. Let's try something else. Let's try to exploit the safe version and see if it can give us. Here it gives me an error, says this 8.8.8.8 colon semicolon ls minus l is not accepted. I can generate different error, but the result is the same. It tells me that this input is not acceptable. The work, it doesn't work, right? So which means that the application here prevented me from exploiting, or doesn't have the vulnerability, so I wasn't able to exploit it, right? So let's go back and see now the application itself. You can see the application from your terminal here by using nano or using less command. So you can do this and you see the command, or if you prefer maybe nano, just make sure that you don't change it. If you happen to change it, just talk to the instructor and they will be able to retrieve the original code, or you can copy it from the assignment. So here you can see the function here test reachability, it takes the address and it takes the option whether it's safe or not. Under the condition if name equals main, here we these are for the arguments, so that you will see them. You can put argument -s for safe or the address, so we need two arguments. And then once we collected the input from the user, we call test reachability. So this part under the condition is not really important. This is just getting access from the user. But these few lines, 5 lines, actually the whole program. So the whole code is here. Let's start by going to the unsafe version of this. The unsafe version takes the address, which is the input from the user, and concatenates the address string with ping -c1. -c1 means send one ping only, right? And the ping is the ping command, the Linux ping command. And here os.system is uses the OS Python OS module, and whatever command we put here as argument or as input to this function, it will be executed as a regular shell command, Linux shell command. So you put ping, it will execute ping. You put ls, it will execute ls. You put anything, it will be executed, right? The unsafe version takes whatever input and just attach it or add it to the ping and then execute it. So initially when I put 8.8.8.8 or 127.0.0.1, now both ping-c1 127.1.0.0.1 is normal ping, right? So it's fine, and the command is executed and the output is displayed, so no harm there. But if the user say, okay, I'm gonna exploit this and add more, so the address is not being checked, so anything that happens after, it's entered here. So if I replace this with what I did before, and I'm just gonna put here as an illustration, so don't do that. So what I put this to exploit the application. So now if you concatenate these two strings, you will see that I am using two Linux commands in one line. The first command is ping-c1, then the address, and then semicolon ls minus -l, right? So that's what the user entered. Now, to avoid doing something like this, you should be able to check the command. The address is supposed to be a string that contains 4 numbers separated by 3 dots. So you could simply say, before I put the address here, I may go and do something like valid address and then check address. So I add a function here that checks the address, and then whatever comes back is a valid address, and I put it here, right? So that's one way to do it. Another way, which I did here, is to avoid this altogether, and instead of using the OS module, I'll use something called the subprocess. So the subprocess module in Python, it takes a list, and the list has the command and then options, a list of options. So I'll let you study the subprocess module by yourselves, but usually this is what it takes. And this prevents, so you'll see here that I will not be able to enter any more um, inputs other than the address. The address itself may be wrong, but it's still anything that's it's not a valid option, it will not be accepted. So I cannot use concatenation here, string concatenation here, to fool the application, right? So this is another way, and I used it here just to make it simple, and also to introduce this sub process. So it's better not to use the OS at all and use the sub process if you want to design application this way. There are multiple ways to validate the input. This is not the only one. Say there may be other methods. If you don't have the sub-process module, or if you don't want to use it, then you have to check that the IP address is actually an IP address and not something else associated with it. So now I'm exiting this and moving on to the next example here. Task 2 is about XSS attacks, which are the cross-scripting attacks. They are mouthful to pronounce. There are two kinds of attacks. So we're going to talk about the reflected attacks first. Again, the same principle. The user or the developer is expecting the user to enter a benign, harmless input, but the user doesn't do that, and instead they put something harmful. This will be through a web interface, and or commonly through a web interface, but could be also through an email or other forms of communication. So in this case, let me again start with an example, and then we'll go into details. So again, it's a single file Python. I'm going to run this command here and go back to the terminal. This code is written using Flask module, and then Flask allows us to create a simple web application without thinking too much about how to create a server and all of that. So the command itself is reflect. And then enter. Okay, so now it says here that running on the local server with port 5000. So what you need to do is go to your web browser and enter your VM IP address. In my case, it's different than yours. HTTP 10.0.115.12. Okay, so the address was for me it's 10.0.105.112, and the port is 5000. And if I can enlarge this a little bit, so you can see here that the input is a form, or the web page gives me a form asking for name and a submit button. Ignore the make safe right now and just say it's expecting me to put a name. Let's say it will. This is a login um, form, or any kind of form where you're supposed to put a name on it. So I may put my name here and enter submit. So your name is exactly what I entered, right? And I can do any other name and it will give me, it will enter the name. The application is supposed to take only pure characters as name, right? So the that's what the developer expects. But if the developer is not careful and they don't check the input, the malicious user may try to say, okay, what if I don't put a name? Notice that any name, any characters that I put in the field, they will be displayed back in the website. So how about I put maybe a script instead of a name? You see in your notes here and your assignment, there are several examples of the things that the user may put. So I'm putting here HTML code, like button, and the button has in on click. And what happens when you click on the button? It will display an alert that tells me this was a mistake, and then this is what's displayed on the button itself. So let's click submit and see what happens. Now, instead of a name, I just entered the button. I added the button to the website. If I click this button, it will generate alert and say this was a mistake, right? Now imagine if instead of doing that, I put more harmful thing. So the alert is a script, JavaScript command that will basically send me a message, send me anything. So I may send a variable here. I may put a variable that I am trying to find the value of. So I may put it here and it will, when I click the button, it will display the value of that variable. Or it could do anything else. So I didn't mention before, but the the reflected XSS attacks are the kind of attacks that uh, the user is affected directly, right? So the one who is submitting the name is affected directly, or it could be, I mean, fooled into doing something like this. I can try different inputs, and I gave you several examples of that. So here I am using again another HTML tag, and this one has the event on mouse over. So these are events, HTML events. So here says click me, and as soon as I hover, as actually not even click, it's a hover. As soon as I hover over it, it will display a message. Now somebody will say, okay, what if that's not harmful? Alert is not harmful, but the idea is any script can be executed, not just alert. I can do something else, right? Let's do something else, or um, let's fool the system into thinking this is a normal name. So now your name is Minor to me, and looks nice. There is nothing wrong with that, right? There is not obvious like click me, but still I hover over it and it will execute that script. I can fool it into displaying an image. So here it's an image, but actually it's more than that. If you look at it, you will see that I am putting an image. The image itself is fake, so there is no image, and it could be a real image. It depends. But here it says on error alert document.cookie. So document.cookie is an important piece of information because the images doesn't exist. So the on error thing is generated, right? So I put an error or a fake image on purpose. Here the cookie says the username is John equals John Doe. John Doe is a variable that was stored on the website. Now you see here the risk is I created or I fooled the website into giving me information that was not I wasn't supposed to see it, right? It wasn't supposed to generate this output, but I fooled it into uh, giving me the cookie. Document.cookie is a well-known variable in JavaScript, right? So I didn't specifically know anything about the application. I just said there is something called document.cookie is known to everybody who's using JavaScript. So let's see what that if I plotted or if I displayed that cookie, what should I get? And in this case, I got the username. Username is important. Or I may get something else, whatever the cookie comes back with. And finally, the last example is the actual JavaScript that I'm entering here, which is, it will give me the same result as before. So I'm putting here a script between these two tags, alert, and give me the document cookie. So now it gave me the cookie. If I do all of this with make safe, let's try again. Last input and submit. Well, nothing happens. It will just the safe version of the application will take the input and sanitize it. Sanitized means that it will just display it as text. No matter what I enter, it will just move whatever harmful part of it and display it as text. So if I'm trying to fool the system into doing something, it doesn't matter. It will just display whatever I put. If I put script, anything here will not work. And so if I submit, it will just display it as a script, as a string, I mean. So in this case, I am if I go back to the unsaved version of this, it will go back to the bad behavior. Okay. Now let's go back to the notes and see what's next. The other form of cross-script attack is called stored attack, and in this case, one user may put the harmful input, and another user is going to be affected by it. So it's not the same. It's not the same user. But before we go into this, let me just give you a quick view of the Python code. So in this case, the Python code, maybe it's better to just go back to the terminal here so we can see more colorful code. So the program starts by it runs the application, right, using the 0.0.0.0.0 actually allows you to get access to this application from anywhere, right? So that's why if you limit it to 127.0 or limited to any IP address, means that the user cannot come from any address but just particular address. But when you put it this way, means that the user can come from any location. Okay, and here there are two functions. So they we will see here that dash form. I'm not gonna go over Flask, but this is how you go into different URLs, right? So this is the form function, and the form function requests data from the form and request the name, so and retrieve it or return it into a username. And then again, like we saw in the previous application, there is the saved version and the unsaved version. So unsaved version will just go and put the HTML and the same HTML that we will see at the top there, and adds a username to it, right? So what is the HTML? This is the HTML that will be displayed, and using the same form, we have the form at the top here, and you'll see the form name form, and then the input, the label, input, input, input. All of these are fields in the form, and then at the bottom here there's your name is, and then we have this curly brackets. The curly brackets in Python, if we use this form HTML, which is the string name dot format, and we put the username here, this username will go into between these or replace these two brackets, right? So in this particular condition, if it's unsafe, if not, request dot form get list safe, so that checkbox is not checked, so it's unsafe. What happens is whatever username we type in the form, it will be put inside or replace these two brackets, and it will be displayed as is in the form. In the saved version, before we change anything, we take the username and use the function escape. The function escape will sanitize, as I said, the input, remove the harmful stuff and return it as just simple text. And then it will put it here. Right. So another thing that I put here, so notice these, the empty string here and the checked string. This is just to make sure that the checkbox that I put there, when if it was checked, it will go back as checked. If it wasn't checked to begin with, it will go back as unchecked. So actually the HTML has two inputs. This one here at the top, if you see, I will go back and show you. So this is an input here and another input. So I'm actually returning the HTML format with two inputs. This one, the first input is just the reflection back. If the user check makes safe, when I enter submit, the check safe is still checked, right? And then the user input is entered. If the check box is not checked, then it will remain unchecked. So this is just to simplify the programming a little bit. But what we need to focus on here is the name, the username. The username is in the unsafe version is entered as is, while in the safe version is entered after we apply the function escape, which I'll let you find out what it does exactly. I explained simply it will sanitize the input, but you can investigate further what it does more specifically. Okay, we'll continue our next example, which is the stored XSS attacks. In this case, again, I'm gonna go and look at the command and then we explain how it works. So back to our terminal. Now instead of reflect, I will use store and enter. No, excuse me, I'm supposed to run it. So we'll go back to the browser. So when I go back to the browser, it's the same address. Just do it again. Let's start a new tab. So remove any old stuff that's there, and let's use this one. Actually, maybe it's a better idea just to start from scratch. Here we go. And I'm going to type the address. You see how I didn't mean it to be this way, but that scripter is still there bugging me because I'm using the same form. So I am going to clear the history. If this persists with you, probably better just to clear the history. All right, so actually, you may notice that I stopped the recording, came back because actually the input persisted. So the only way I could um, um, get rid of it is by stopping the application. So what I did, I stopped the application altogether. So went back, did Control C here. I started, went back to the browser. I went back to my address here, make sure that it was clear, and then I started the application again, and now I have clean slate, so I can get rid of, or I could get rid of the um, old input. But that actually a good problem to have, because it will tell you that whatever input somebody puts in there, it will be persistent with other users. So the idea here is slightly different. So sometimes you go to a blog and you find the blog and then the comments at the end, or you go to a website, Amazon for example, and you'll find reviews for a product. So these are input that or input came from users, and it will persist there. It will be displayed, maybe stored in a database and displayed to the user or the other users, right? So what we will do here is put a malicious code, and we'll see if other users will be exposed to it. So let's say I am putting a comment here. I'll say, well, this product is nice. So that's not very harmful. If somebody else, another user, go and let's say another user comes, they will see the same uh, output from somebody else, right? So same comment from somebody else, no problem there. Now let's see if I can put something harmful, right? So our notes will show here few examples of things that can be used and they are harmful. So we'll pick the first one here, which are similar to the previous examples. So now I'll say my name is bad user, and I'll put something harmful here, submit. Maybe I'll do something else. Okay, so let's assume somebody else. So I put these names. Let's say somebody else go and to this unsuspected website, or to this website, and say I am going to go to this website and check the reviews. All right, so as soon as I hover by this, the script is executed. I may click on this and also the script is executed. Now I'm not the same user, right? So it's somebody else. I may do the same trick as I used before. So again, another bad user will say evil in this case. Actually, the script is let's see if that it's generated alert, and in this case I didn't even have to type anything. As soon as I visited the website, that code is executed. So let's do it again. Let's imagine somebody else going to this website and entering. As soon as I go to this website, this script is executed. Right? In addition to these, this maybe say, okay, the user may not be clicking on the button, maybe not hovering over this one, but they have no control over the scripts that I added, which is as soon as the page is loaded, the script is executed. So how to make this safe, right? Or what is the difference? So now before I show you the safe thing, let me click on this is safe user and really um, safe comment and make safe. Actually, this is safe either way, but let's say submit. The user entered safe comment and I made it make safe. I click submit. The page refreshed. Because it refreshed and it had a bad comment, a script there, that script is executed. Right? So let's say another user coming and they will go to the same website. Code is executed again. My point here is make it safe. So a bad user, just single bad user puts a bad comment, it will affect all the users, no matter whether they come back and put decent comments, safe comments or not. It's gonna affect them no matter what. So it will affect everybody. So let's get rid of this. Close the application and then run it again, and this time I'm gonna run everything safely so we don't have these issues, hopefully. So 10 code again, the form, save comment for my name, save comment, make safe, enter. Bad user trying to enter something bad like this one and submit. Because now the code is safe, the bad user cannot enter a bad comment. The bad comment will be sanitized and entered as only text. Right. So now again, if I do this with other scripts, let's say I'll enter the script in the assignment. Still okay because the safe code will prevent the user from entering any scripts. It will display as a script, right? So let's go and take a look at the code now. So I'm just going to enter nano and see the code. So similar to before, I have this HTML code, and this time the HTML is two sections, so HTML and HTML comment, and I have a list of comments, so they are persistent. Imagine a database where every user puts a comment. That comment will stay for the next user, so they don't go away. The code as before, there's a form. If the input is not safe, then I'm reading the name and the comment, and we are inserting in the HTML, we are inserting the username and the user comment. In the safe mode, I am inserting escaped username and escaped comment. Remember, we have to sanitize both inputs, not just the username, because I can still do access attack on the username. I can still do what I did before, right, on the username. So we have to sanitize both of them. Right? And then we have to we take this input and display the code. The comments are stored, so the get HTML function store where is the yeah, so the HTML function here will generate HTML code by taking all the comments from the list and adding them. So that's why when you see the website, you will see not just one comment but all of them, every comment that we entered. The new comment that the user entered will be added to the old comments. So actually, maybe I'll explain it better here. So the comment dot insert here takes the list, which is comment, and insert this new comment, the username and the comment in the first, as an object in the first item. So this is like what is it? The last input comes at the top, right? So in the chronological order, you see the newest comment at the top and the oldest comment at the bottom. To do that, I have to insert the objects always at the 0 index of the list. If I want to add it at the bottom, I will say comments.append, right? Not insert. So this is the explanation of this line here. So my object, which includes the name and the comments, are entered at the 0 index. Here in this safe version, they are escaped first and then they are entered. And then what I want to display is the output of the make response. Sorry, the output of the get HTML. So that's the response to the submit command. The get HTML again takes input as safe or not safe if I change it, and then generates a string and then returns the string to the HTML. Okay, so if you don't understand exactly what I'm saying, uh, I'm trying to be brief here, but you can trace the Python code and it's not that difficult to get. It's really simple, and you can add to it if you wish. Okay, now we'll go back to the assignment and look at another form of injection attacks, which is SQL injection. So SQL injection applies to databases, right? The most common form of databases is the relational database. It has most of the databases are relational databases, and the relational databases characteristic is the database consists of tables, and the tables consists of rows, right? And each row consists of fields. So and you can add to those tables or update the contents or retrieve the contents using a common language called SQL language or SQL query language. So this is very common. It has been around for a long time, and there are variations of it, but it has similar syntax regardless of what kind of a SQL database you're using. So we call them SQL databases because they can be accessed using SQL. So whether it's MySQL or any type of other forms, Oracle or any other form or any other database type, they're all similar, more or less. Okay, so because they're more similar and because they're widely used, well, guess what? A lot of hackers develop techniques to attack these databases. So what we're gonna do now is try to find out how we use injection attacks to get more information from a database, more than what we are allowed to do. So the assumption here is we have a small database that has salaries of employees, and the intention of the application is only the managers are supposed to know what their employees' salaries are. So the database has let me see if it's shown here. So in this part, well, the name of the employee is John. They're earning 36,000, and their manager is VJ, right? And Anne earns 44,000, and their boss is VJ, and so on, right? So the application is supposed to allow the manager to look at their employees' salaries. So this is what we will do. We will execute this command here, and we will see what the output will be. I'm doing Python 3, and I am running the SQL injection, and I'm supposed to enter the name of the manager and see what happens. So if I put a manager here, what comes back is the output is empty because there is no manager with the name Mark, right? But if I say VJ, and you have to make sure that it's case sensitive so you have to enter the name correctly. So I entered VJ, and VJ has two employees, John with a salary of 36,000 and Anne with a salary of 44,000. If I put Bill, that's a valid manager, and under Bill there's VJ and Ying. Okay, so that's the normal operation. If I put a wrong manager, it will give me no output, right? And I am assuming here again, for simplicity's sake, I'm assuming there is a username and password before, like you can just, maybe somebody will just start guessing names, and they will get the result. But I'm assuming there's a step about login, so before somebody can access VJ, for example, will not be able to execute this command un unless they authenticate first. So we're skipping this step for simplicity's sake. Now, because the SQL commands are very well known, somebody may take an advantage of the SQL structure and try to fool it into doing something that's not supposed to be doing. So before I do this, I think I feel like I need to explain some of the commands first, and then we'll see how we fool them. So I'll go back, or maybe, yeah, let's go back to the notes, and you'll see here this statement, unfortunately, is not clear, but the SQL statement that I want to explain, that I want to execute, is select asterisk from employees where manager equal and the manager names comes as an input to the function. So this is the input. This is the argument to the function. Right? So that's the statement, the SQL statement that will retrieve, asterisk here means retrieve all the fields from the employees table. The condition here is where, and the condition is the manager equal the manager of, so we have a field called manager, so that's the manager field equal the manager name that we entered. So the manager here, the first manager, is the field name, and the value is supposed to be the manager name that we enter as input, right? So that's when we executed the command, as you saw before, we supplied the manager name here. Okay, but the idea here is there is a select from employees and there is a condition. Okay. So, and the condition has to be true, otherwise it will not execute. It will give us empty list. So when I put my name, the manager equals Mon, there is no manager here with the name Mon, so this executed to false, and therefore the statement came back empty, or the result came back empty. Alright, so here is the exploit. In the SQL injection, there are many forms of exploits, not just one, but one form is, what if I fool this into returning true all the time, whether I know the manager or not, whether I know the name of the manager or not. So this will give me back the list of all people regardless of the name of the manager. Okay, so let's do that. To do that, I have to enter this command here, and I will show you how it works. So let's say, for sake of illustration, I don't know who the manager is, so I'm gonna put any fake name. Actually, maybe I'm not even put a fake name at all. I'm just typing this is the quote sign, or 1 equal 1 semicolon and these double dashes. Enter, and look, I retrieved all the names for all employees. So what just happened here? How did that happen? Okay, let's see. I'm going to maybe start just a temporary note here, and I'm just gonna copy and paste the command that I just executed. So this was supposed to be the command that this is exactly what was supposed to be executed, right? So select the asterisk from employees where manager equal, and pay close attention to all of these single quote or double quote thing. So the because it's a string, so the string actually includes, that was quote here and a double quote. So this part is a string, and then plus, and then the manager, which is an input. It's a variable, string variable. Then plus, then another double quote, single quote, semicolon, and another double quote. So the command that's supposed to be executed, if I put a legitimate name, this was supposed to be executed like this. VJ, let's say VJ. Oh, VJ is gonna kill me because I don't know how to spell his name. I forgot. VJ, sorry, I forgot how to spell your name. This is it. And, well, I'm getting old. So that's the command that's supposed to be executed. And if I execute this command, only the employees who has managers VJ will be displayed. If I put Mon here, no manager named Mon, so the command will come back, or the result will come back empty. So how did I fool it? I fooled it by saying, what did I say? I say, remember I put a single quote, right? Then I put or 1 equal 1 semicolon, then double dash here. Okay, so, and probably there is a space that I forgot, but so so now the where condition is manager equals nothing. This will return false because there is no manager equal empty space. All managers have names, so this will return false. or 1 equal 1. 1 equal 1 will always return true because 1 equal 1. And then SQL, SQL language, consider anything after the dash dash as comment. So this is the equivalent of hashtag in Python. So this is a comment. So anything that's come after it is comment. So now the where evaluates always to true. So what happens here? Select everything from employees where true. Because this is always true, we get a list of all employees, no matter what the name is. I fooled the system into giving me all the information without without giving any legitimate manager name. So that can be used. Let's say I am an employee. I am Mon, right? I am an employee, and I have access to this, but I want to get more access, not just for my own employees, but I want to access to everybody's. Maybe I want to see uh, if my boss, oh, how much money my boss makes. So I'll go and check, or my colleagues, right? And it could be used also by external hackers, right, to collect information uh, about employees too. So that's the idea behind SQL injection. And I let you consider like what are the other scenarios that you may do, or what other things that you can do to simulate an SQL injection, but in a different way. Okay, so how can we make this safe? Right, let's see if we change this and do -s, so make it safe and enter, we get empty. So now it's becoming safe. I cannot fool it anymore. Let's try to put my name, nothing, obviously, because I'm not in the I'm not in the database. If I put VJ, that's legitimate, so I get all the employees of VJ. Okay, so let's go and take a look at the code. Oops. So the code has two parts. The first part is creating the database itself. So here we see, if you are interested, you see how to create a quick database. So if the database is there, it will not create it twice. So it will be created only once. Right. It will create a database and it will populate it. So that's not really important to us right now. It's a good exercise if you want to know how to create a database very quickly. And we are using SQLite to create this database, which is a single file database, and it's easy to use. Here is the function that we are interested in, which is the get salaries. The get salaries, if I use the unsafe, so here I'm creating a statement, and the statement is concatenation of 3 strings, the prefix that I always need, and then the manager name, and then at the end the semicolon here. Then this is a print so that I can see what the command is entered, right? So this is for the purpose of the lab, right? But this is the command that will execute the statement. So the cursor execute and the statement goes in, and then what we get back is the something. So we use something called fetch all to get back all the rows, and then we will display the rows one by one. Here is another um, form of the statement, but we are using something called parameterized queries. So rather than concatenating the strings like this, I am entering a tuple with all the inputs that I want. The tuple has to be always there, but since I have only one input, so the other part is empty. And I have this form that it says manager equal, and then these brackets and the question mark in between. Again, if I have multiple inputs, I can put multiple question marks inside the brackets separated by commas. So I'll let you do your research and find out uh, more about this form versus this form. So this is the simplest form, right? So the statement is a string and I'll execute it. This is more of a parameterized form, and it's always recommended that we use this because it's safer. It's not entirely fool proof. You can still fool it, and if you find ways to fool it, let me know and share it with us. But this is more this I cannot fool this as much as the other one, because if I put it's supposed to expect the whole thing here as a manager. So whatever I entered here, it goes as equal to manager. And so when I put uh, single quote or 1 = 1, it looks in the database, or it looks for a manager called or 1 = 1, and of course there is no manager called or 1 = 1, so it will not it will return empty, right? So now instead of the concatenating the strings and using this to fool or create actually multiple statements, or a statement with different with a true condition all the time. Here, whatever I input, even if it's malicious, it will consider it as the name of the manager. And of course, I have a limited number of manager names, and that malicious center or characters are not legitimate manager names, so it will return empty all the time. So that concludes all the examples. So as I said in the lab, in the lecture before, some of the programming languages are by their nature are immune to some of the attacks. So actually, this injection, there are multiple injection SQL injection forms. I couldn't do most of the SQL injection attacks because some of them they rely on an idea similar to the command injection, where they put two statements back to back and the second statement is executed when the first statement is executed. I couldn't do that in Python, because this form, this Python module, it doesn't allow me to do that. So I actually worked very hard to find a vulnerability, and I found this way to use the vulnerability to illustrate SQL injection. So some languages have built-in immunity against some attacks. Another form of immunity that Python has is the buffer overflow, because all arrays have uh, um, predefined size. If I go and try to access something outside of the array, it will give me an error. It will give me an index error. If I try to access an object or an object with a keyword that does not exist in the object, it would give me an error. So some of these are you cannot replicate them in Python. Others you can, right? So JavaScript has some vulnerabilities. Python has maybe different set of vulnerabilities. Um, so that concludes all the examples. Please go through the questions and try to answer them. And if you have ideas about more uh, attacks or more vulnerabilities that we can use, please share them so we can update our lab, make it more instructive and more useful. That's it. Thank you very much. I'll talk to you in a different lab recording. I hope you enjoyed this demo. Thank you and bye for now.